Hello, so in this video we're going to look at chapter 6.2, Factoring Trinomials. There will be 4 topics that we will go over, and in the description below there will be the chapters for the video, so you can jump to certain sections that you're looking for. There will be a link to the first and second edition of the Intermediate Algebra textbook, and a shared folder that you're welcome to look at additional notes and resources, along with a survey at the bottom. So first, we're going to talk about the factoring trinomials form x squared plus bx plus c. And so when they're in this form, you are able to put them in binomials. And only when they're in this form, typically you would have the form ax squared plus bx plus c. And you would take a times c, and that would give you a value when they're multiplied together. But then it would have to add to get another value. So those factors of this AC need to add up to B. But when you get those values, you're able to put them directly into the binomials. So if we had -1 and 2, and that worked to add up or subtract to that value, we would literally put in x minus 1, x plus 2. But that's only when they're in this form. So let's look at some examples. So we're given m squared minus 13m plus 30. And so if we look at the a and the c, we can see that a, b, and c, and so we can see that ac would equal positive 30, and b would be a negative 13. And so looking at the factors of 30, we can see that we would have 3 and 10, 1 and 30, and 2 and 15, and we would possibly have more, 6 and 5, and so on. But when they're subtracted together, so we can do, since we want a positive, we could do a positive times a positive, or a negative times a negative, and still get a positive. But since we want a negative value, when they're added or subtracted up to, we would do subtraction. So since we want a negative 13, we would do negative 3 minus 10, which would give us a negative 13, which checks out. And so we can put them directly into our binomial, and so our answer would be m minus 3, m minus 10. For the next one, we have 6n minus 7 plus n squared. And so first, I would put them in descending power, or variable, to where we have n squared plus 6n minus 7. If we look at our a and c, we can see that a would be 1, b would be 6, and c would be negative 7. If we look at our ac and b, we can see that AC would be negative 7 and a positive 6. And so we know that the factors for 7 would be just 1 and 7. But since we want them to would be negative, we could have a negative 1 and a positive 7, or a positive 1 and a negative 7. But since we want it to add up to 6, negative 1 and positive 7 would be our answer. And so putting those into the factored form, we would have n minus 1 and n plus 7. So next we're going to look at using the trial and error method, not a method that I would recommend, but it is possible to do. So for this, we are given a polynomial in ax squared plus bx plus c, and we want to take 2 binomials to give us, and we can FOIL them to where we get the original equation, or a pattern. So we're given 3y squared plus 22y plus 7. And so we can see that we're going to have a couple different binomials, which is a reason why I don't suggest this method. So we could do y plus 1 and 3y plus 7. We could also have y plus 7 and 3y plus 1. So if we looked at foiling them, we would have, on the top, we would have 3y squared plus 10y plus 7. And since that is not our original equation, that does not work. If we looked at doing the bottom one, we would get a 3y squared plus 22y plus 7. And so our answer would be y plus 7, 3y plus 1. For the next one, we have 3m cubed minus 21n squared plus 30m. And so first, I would pull out the greatest common factor. So if we pull out a 3m, we're left with m squared minus 7m plus 10. If we looked at doing the same process, the trial and error, we could have m minus 1 and m minus 10. We could also have m minus 5 and m minus 2. If we looked at foiling those, the top one would give us an m squared minus 11m plus 10. And on the bottom, if we looked at foiling, we would get an m squared minus 7m plus 10. And since we want the bottom one because it gives us back our original polynomial, our answer would be 3m in parentheses m minus 5 and in parentheses m minus 2. So next, we're going to look at factoring trinomials using the AC method. And so with the AC method, we look at taking our A and our C value. We're going to be multiplying those together. And then for our B value, we want those factors to add or subtract to the value that we have for B. So let's look at some examples. So in the first one, we have 63n squared plus 150n plus 75. And so since we can see those are pretty high numbers, but we can actually factor out a 3. Factoring out a 3, we would get a 21n squared plus 50n plus 25. If we looked at our A, B, and C value, our A being 21, our B being 50, and our C being 25, we can plug into our calculator 21 times 25 and get 525 positive, and we would have a positive 50. And since we want to look at the different factors for it, we would have 1 and 525 and 35 and 15. But since we want a 50, our top row wouldn't work, but our 35 plus 15 would work. We would split the B term or the middle term. We'll leave the 3 out front, and in parentheses, we would have 21n squared plus 35n plus 15n plus 25. And so now we're just factor by grouping. And so we have our first one and our second. And in the first one, we can see that we have a 7n in common. Pulling out a 7n from 21n squared, we would have a 3n. And pulling out a 7n from 35n, we would have a positive 5. And since we want this 3n plus 5 to come back, we could pull out a positive 5 and get a 3n plus 5. And so our answer would be 3 in parentheses 7n plus 5, 3n plus 5. For the next one, we have 36m to the 4th minus 12m cubed minus 8m squared. And so first, I would pull out the greatest common factor. If we pulled out a 4m squared, we're left with a 9m squared minus 3m minus 2. If we look at our a being 9, our b being negative 3, and our c being negative 2, if we looked at the a and the c and b, we can see the ac would give us a negative 18, and our b would be a negative 3. So we can look at the different factors for 18. I'm mainly going to look at negative 6 and a positive 3, and a positive 6 and a negative 3. Since we want a negative 3 to be returned, or our factors to subtract 2, negative 3, or add up to 3, we could take negative 6 plus 3, and that would give us a negative 3. So the one on the bottom, 6 minus 3, would give us a positive 3, and since we want a negative, the top one would be what we're going to be using. So if we look at splitting the middle term, we would have 9m squared minus 6m plus 3m minus 2. We would be factored by grouping again, and we would have our first group and our second group. And in the first group, we could see that we have a 3m in common. Pulling out a 3m, we would be left with a 3m minus 2. And since we want this 3m to minus 2 to come back, we could just put a plus 1 and 3m minus 2. And so our answer would be 4m squared in parentheses 3m plus 1 and 3m minus 2. So next, we're looking at 12z squared minus 41z minus 11. And so this one we can't factor, so we would take our a being 12, our b being negative 41, and our c being negative 13, and our c equaling negative 11. We could see that a times c would equal negative 132, and b being negative 41. And since we want our factors to subtract to negative 41, we could look at 3 and 44, a positive 3 and a negative 44, or a negative 3 and a positive 44. When the top one is subtracted, we would get a negative 41, but when we do the bottom, we would get a positive 41. And since we want the top one, that's what we're going to be using. If we look at splitting our middle term, our b value, we would have 12z squared plus 3z minus 44z minus 11. We're going to be factored by regrouping again. We can look at our first group and our second group, and we can see that in the first group we have a 3z in common. Pulling out a 3z, we're left with a 4z plus 1. And since we want this 4z to come back, we want to pull out a negative 11. And we do have a negative 11 in common. So we would have a 4z plus 1 to come back. And our answer would be 3z minus 11. And in parentheses, 4z plus 1. So next we have 30x squared plus 105x minus 60. And so we can see that our greatest common factor between each of the three terms would be 15, and so we want to make sure we pull that out first. So pulling out a 15, you would have 2x squared plus 7x minus 4. If we look at our a value being 2, our b value being positive 7, and our c being a negative 4, we can see that our a and our c will equal a negative 8, and our c and our b would be a positive 7. If we looked at the factors of 8, we could have 1 and 8, 2 and 4, but then we have to also look at the signs. And so since we want a negative, 1 would have to be negative, 1 would have to be positive. So I'm going to look at positive 1 and negative 8, and then a negative 1 and a positive 8. But since we want it to add up to 7, 1 minus 8 would give us a negative 7, negative 1 plus 8 would give us a positive 7. And so that is going to be the one that we're going to be using. So if we look at splitting the middle term, we keep the 15 out front. We have 2x squared minus x plus 8x minus 4. We're going to be factoring by grouping again. We have our first group and our second. We can see in the first group we just have an x in common. And so we're left with a 2x minus 1. And since we want this 2x minus 1 to come back, we can see that if we pull out a positive 4, 2x minus 1 comes back, and our answer would be 15, 2x minus 1, x plus 4. So next we're going to look at factor by substitution, and typically the textbook would use u for substitution, so we would let m or u equal some value or polynomial, and it's pretty common, so you would have u equaling 1, and you could use u squared equaling this, and you could keep going, but then you would just use it to find out your problem. So if you were using it for a trig function or something, you could do it, and then you could go back, replace those values, and you could get an exact answer rather than trying to use it with those values. So in the first one, we have x minus 2 squared in parentheses minus 3 in parentheses x minus 2 in parentheses minus 54. And at first glance, this would look ugly. So we could let m equal x minus 2. And so m squared would equal x minus 2 squared. So we would have m squared minus 3m minus 54. And it's just the first topic that we were talking about. So we have an x squared plus bx plus c. And so since we can see that our factored form would be a positive 6 and a negative 9, we would just have m plus 6, m minus 9. Putting our values back in for m, we would just have an x minus 2 plus 6 and an x minus 2 minus 9. If we add and subtract, we can see that our answer would be x plus 4, x minus 11. So next we're given x to the 4th minus 4x minus 5. And so we could let m equal x squared, and so m squared would equal x to the 4th. If we look at replacing those values, we would have x squared. We would have m squared minus 4m minus 5. And we would see that this would be a similar form to the x squared plus bx plus c. And we could see that we would have a positive 1 and a negative 5. And so our answer would be m plus 1, m minus 5. Plugging those values back in, our answer would be x squared plus 1 and an x squared minus 5. So next we're given in parentheses 5y minus 1 in parentheses squared minus 3 in parentheses 5y minus 1 and parentheses minus 18. And so we could let m equal 5y minus 1, and so m squared would equal 5y minus 1 squared. So we would have m squared minus 3m minus 18. We can see this is a similar form, and so we would have a negative 6 and a positive 3. And so we would have m minus 6 and m plus 3. Plugging those values back in, we would just have a 5y minus 1 minus 6 and a 5y plus 3 minus 1. Combining like terms, we would have as an answer 5y minus 7 and a 5y plus 2.